A stone is thrown upwards at a speed of 12 meters per second from a cliff 70 meters high. How long does it take to reach the bottom? What is the speed just before hitting the ground? And what is the total distance? So the best thing to do with physics is draw what's going on. So you are on a cliff. Okay, so here's my cliff. This is the ground, and here's my cliff up here. And let's say some guy or girl is, so this is a hand, and the hand, that's your hand, and you have a stone. And you're throwing it up. So it tells you at a speed of 12, right, meters per second. So they give you the speed, but then they tell you the direction. So they could have just said, you know, at a velocity of positive 12 meters per second, but this time they decided to break it up. So it's upward speed of 12 meters per second. And this is 70 meters high. How long does it take to reach the bottom, right? So what's going to happen? Let's change colors. This stone is going to go up. It's going to go up. And then it's going to fall down. And it's going to hit the bottom. So this is kind of the trajectory of the stone. So we need to see it's going to go up. It's going to hit a maximum point. It's going to come down. And then it's going to go all the way. So how long does it take? Let's go back. That so we got to translate English to physics. So that basically means, what is my time, right? What variable are they asking? Always try to figure out what variable are they asking. What is the speed just before hitting the ground, right? That's your V final. And actually, they're asking for speed, not velocity final. So, but once we figure out velocity final, we can just give them the speed, right? We can just give it to, we can figure this out without the direction. So, in general, they're asking what is V final. And total distance. Okay, now total distance, there's actually, you can't just say that's delta x, right? Or sorry, we're in the y direction. So you can't just say this is delta y. Because delta y is the change in distance. And the change in distance is, we already know, negative 70. Right? We start here, we end here. So that's your change. It's negative 70. Whereas the total distance, so let's get rid of this. The total distance is what's in blue, right? You go up, you go down, and then you have the 70 meters. So you have to account for, right? You have to account for all this. You have to go up, you have to go down, and then you have 70. So total distance, there really is no variable for that. So we'll show you how to do this, but you know, that's part C. So let's go one at a time. So what do you do? First thing, right? Hardest part of physics is, how do I begin? So very easy in kinematics. There's only 6 variables to describe motion. So let's write all 6. And we're in the y direction. So we're just going up and down. So what are the 6 variables? Well, I have an acceleration. Hopefully this is becoming more second nature. The initial, 6 ways to describe motion. The final, y initial, y final. 6 ways. What is my acceleration? Again, gravity is going to cause every object to accelerate down, so that's negative, at a rate of negative 9.8 meters per second squared, regardless of the size of the object, the weight, etc. It's always this. Okay, what is the initial velocity? So this time, right, we are throwing. We are throwing. So throwing in English means you're giving it a little bit of a push. You're giving it a little bit of an initial velocity. We're not dropping or falling. We're throwing. And they tell you at a speed of 12 meters per second up, which means a right? Up means positive. So basically your velocity is positive 12 meters per second. So this confuses people sometimes because notice something. Your initial velocity is up, but your acceleration is down, and that's allowed. Like, you don't have to have everything going. You think, oh, the ball is going up, so everything should be positive, right? But you can't just say, oh, everything's positive because the ball is going up. You have to look at it for each variable, what is going on. So you can't just generalize. So the velocity, the initial velocity, is being thrown upwards, right? If we were throwing it down, then it would be negative, but we're choosing to throw it up. And then gravity always accelerates objects downwards. So it is slightly confusing, but just kind of run through this in your head. Look at each variable separately. The initial velocity we're throwing up, the accelerating is happening downwards. Okay, what's my final velocity? I don't know. That's what I need to figure out. What's my initial height? 70. What's my final height? 0. And what is my time? Don't know. Again, also need to figure out. So let's do that one first, part A. So how do I get time? Which of those equations has time? So you can do v final equals v initial plus at, but we don't know v final. So the only other one is delta y is vit plus 1/2 at squared. Delta y is final minus initial, so 0 minus 70 is negative 70. The initial is 12 times t plus 1/2 times negative 9.8 t squared. If you plug all this in to a calculator, you will get, give me a second to do that, what are you going to get? What are you going to get? You are going to get, well, you're good. This is a quadratic, right? You have a t squared, you have a t, and then you have a number. So if you do the quadratic formula, which, is a pain, you're going to get negative 2.7 or 5.19. Because remember, with quadratic formula, you get two numbers. So which one is it? Well, time cannot be a negative value, right? At least in this universe, not to my knowledge. So we're going to keep it at 5.19 seconds. That is the time it takes to go up and down like that. Cool. That's your time. So no longer a question mark. Now we know it. It's kind of like being a detective. You're given some clues and then you have to figure out these other ones. Anyways, what is the speed just before hitting the ground? What is your final velocity? Okay, now we can do v final equals v initial plus at. We have every single variable. So really you can use this equation, or you can use the other one, v final squared equals v initial squared. I'm sorry, let me just write it out. V final squared minus v initial squared equals 2a delta y. You can use this one too, but look, it's such a pain, so I'm just going to get rid of it, right? There's too many variables, there's squares, so use the simpler ones when you can. But you don't have to, you can use that as well. So v final equals 12 is your v initial, your a is negative 9.8, your time is 5.19. So what is v final? Negative 38.8 meters per second. Cool. Okay, so we've gotten this, we've gotten this. How do we get this total distance, right? Because you can't just say negative 70. That's your change. But what's the total? So if you think about it, we're going to use the exact same theme that I elaborated on in the last video, which is break up the motion, right? You don't have to describe the entire motion from beginning to end. You can look at different parts. So this is a huge theme in physics. Let's just, instead of looking from, beginning all the way to end, let's look from beginning to the top. Okay, let's just look at this motion. Let's just describe this motion here when it goes up here. So how do I do this? Well, let's erase. What should I erase? I live in a crowded city, so we will hear, I don't know if you can even hear the fire truck in this video, but sorry about that. Fire truck just went by. Hopefully the person's okay. Okay, so let me switch back. Let's just describe this motion. So what should I call it? From cliff, right? We're at the cliff to the peak. So this is the peak. So let's just describe this motion from cliff to peak. What was this motion we were describing here? This was from cliff to bottom. So this we were describing the entire thing, right? From cliff, to bottom. Okay, but here we're going to just drive cliff to its peak. So let's just describe this motion right here. So how do I describe a motion? 6 variables. Always the same 6. V initial, V final, Y initial, Y final, time. So what's the acceleration of the stone, right? It's the same stone, and gravity is pushing down at a rate of negative 9.8 meters per second squared. Gravity is pushing, I should stop saying this word pushing. It's causing the object, the stone, to accelerate down, hence the negative, at a rate of 9.8 meters per second. So negative 9.8. What is the initial velocity? Same thing, it's 12. Right? You're starting at a speed of 12 meters up, so it's 12. What is the final velocity? What is the velocity at its peak? Okay? And they don't tell it to you in the problem, but this is another just thing that's going to soon become intuitive to you. So think about it. When you throw something in the air, you gave it a speed of 12 meters per second going up, so it has a 12 meters per second up. But eventually, right, you're going to reach, there's going to be a second where this is going to have a velocity of 0, right? Because it's going to slow down, bam, it's going to hit 0, and then it's going to fall again, right? Because if it didn't reach 0, it would just keep going up forever. So it's going to slow down, and then it's going to fall again. So just think from your own experience, if you throw an object up, it's going to eventually reach a 0 meter per second speed for a second, right? For a slight second, it's going to be 0, and then it's going to fall again. And if you want to look at the physics behind it, now that we're physics experts, we started at a velocity of positive 12, and every second we are going down 9.8, right? Meters per second per second. So after 1 second, we're going to be around 2 meters, right? We're going from 12 minus 9.8, that's going to get you 2. So a little over a second, and we will actually reach 0 meters. And then we're going to pick it up again. So anyway, so 0. So that's your velocity. So let me write this in words. This is another theme. Theme number 2, right? From the last video I gave you one. So peak equals V final of 0. And they won't necessarily tell you in the problem, right? Because they're not going to tell that to you in the problem. It doesn't say it anywhere in the problem. By the way, when you reach your peak, you have a 0 meter per second. But you can just now you know it is. So you can use that. There's a lot of things in physics that you kind of have to figure out before you go in. So this is one of those. Cool. What's the initial position? 70. You're 70 above. What's the final position? We don't know. And what is the time? Also unknown. So what are we trying to figure out? Well, if we figure out the final position, right? If we figure out this y final, then we will have known this height right here, this distance traveled. So if we figure that out and we get this distance traveled, then the distance that comes back down is exactly the same, right? So let's say this, I don't know what this number is, but let's say it's 10, right? You go 10 up, then you're also coming 10 down, and then we can add it to our 70, and that'll get you your total distance. So let's figure out what that actual distance is, because I just made up that number. So what is y final? How do I get displacement? So there's only 2 equations I can use. Delta y equals VIT plus 1/2 AT squared. But that one has t in it. And remember, I don't have time. So really, if you're not given time, there's only one equation to use. It is this. So it's kind of like people usually don't like this for some reason. It just looks scary. V final squared minus V initial squared equals 2a delta y. I personally love it when the problem does not give me time, because I know exactly what to do, right? There's only one equation that doesn't have time. So if I'm not given time, and unless I have to figure out time, then obviously you don't use this. But if you're not given time and you need to figure out another variable, you use this equation. It's like go-to. So V final squared minus 70 is your initial. I'm sorry. Your initial velocity is 12 equals 2 times your acceleration, negative 9.8, let me try to write smaller. 2 times negative 9.8. And then delta y, what's your delta y? You're going from, oh, and sorry, your v final is 0. There you go. See, I was like, why do I have so many variables? So you have 0 minus 12 squared. It's 2 times negative 9.8. And y final minus 70 is your delta y, right? So y final minus 70. Sorry for this messiness. And if you do this, you will get y final. If you plug all that into your calculator, what are you going to get? Let me tell you in a second. Y final is going to be 77.34 meters. Okay, so this height here, this position here is 77.34. So what's my total distance? Well, I went from 70 to 77.34. So let me switch colors. Let's go just straight up. No, let's do this. Okay, so going from 70 to 77.34, that means you went up 7.34, right? If you just subtract 77.34 minus 70, so you went up 7.34, you have to come down 7.34. And then you went down another 70. So add these up. 7.34 plus 7.34, that's 14.68 plus 70. That is 84.68 meters. That is your total distance traveled.